Hi, my name is Travis Connor, and this presentation is about Lab 1 Constant Velocity. The purpose of this lab was to visually display constant velocity as a result of a net force of zero. In this lab, I created a model of a real-life situation where a soccer ball is rolled with constant velocity across the floor. The system is the ball, and the surroundings is the air and the floor. This situation is to display a net force of zero, which results in constant velocity. I also created a computer model of the ball moving with a constant net force in a virtual setting. This lab overall showed that my real life situation had a constant velocity similar to a perfect situation with no net force. A net force of zero will result in a constant velocity because without a force acting on an object, its velocity cannot change according to Newton's second law. In this situation, the ball starts with a constant velocity that does not change. With the video I created, I put into Tracker to plot its position versus time. I had some difficulty plotting the position of the ball over time because for some reason the ball would seem to go backwards in the frames even though it was moving forward the whole time. I fixed this by only plotting the times where the ball was moving forward. I also oriented my situation so that the ball moved in the direction of the positive x-axis. If the ball moved in the negative x direction, the velocity would be negative and the position for each plotted point would also be negative. Time, however, would stay the same. Anyways, after dividing the last point, 1.083 meters, by 1.067 seconds, I was able to identify the average velocity over the elapsed time, which is 1.015 meters per second. I then used this average velocity in my model, and that can be seen right here. The model which we can see now has the same constant velocity as the observed situation. In my model, I assume there to be no net force acting on the soccer ball during its movement, which can be seen here. I also changed this line of code, which can be seen here, so that the distance traveled by the ball was very similar to real life. It is not possible for me to say how many pushes or pulls are added together to give a net force of zero, because I do not know all of the forces acting on the ball as it rolls. I know that there is friction from the ground and air resistance from the air, but there could be additional forces acting on the ball, resulting in a net force of zero. Anyways, a net force of zero allowed me to get a model very similar to the real life situation. After creating my model, I compared the observed position versus time to the predicted position versus time in Excel. I plotted the observed positions and times in Excel along with the predicted positions and times to create a scatter plot with both datasets. Here's the observed data and here's the predicted data. I use a scatter plot because it allows for the differences in data to be clearly seen. The predicted positions had the same times as the observed times. It can be seen that the observed trend line is almost identical to the predicted trend line, but is slightly off. Differences could be the result of a non-constant velocity in real life because it is hard to replicate. Overall, my two models are very similar to each other, displaying a constant net force of zero.